Hello, this is Abuzar from Math Concepts channel. In this video, we find k permutation of n, that is the number of ways we can put n distinct objects in k different places without object repetition. Please subscribe to this channel to watch and learn more about conceptual mathematics problems. Let P of n and k denote the permutation of n distinct objects in k different places without object repetition. Note that k permutation of n without repetition is also shown with other notations such as npk that reads as n permutes k. We assume that number of objects is greater than or equal to the number of places. We show that P of n and k equals to n factorial divided by n minus k factorial. Note that n factorial is defined as multiplication of integer numbers from 1 to n. As an illustration, let's find 2 permutation of 3, that is the total number of ways we can put 3 distinct objects in 2 different places. Let's form all possible tuples in 2 permutation of 3. We have 3 different options to fill the first place with one of the 3 objects 1, 2, or 3. So total number of ways to put an object in the first place is 3. Now, as repetition is not allowed, we have only 2 different options to fill up the second place with one of the 2 remaining objects. For the tuple with 1 in the first place, we can fill the second place with 2 or 3. For the tuple with 2 in the first place, we can fill the second place with 1 or 3. And for the tuple with 3 in the first place, we can fill the second place with 1 or 2. So we have written all 6 possible ways of permuting 3 different objects in 2 different places. Note that we sequentially placed each object in each position. So placing an object in the second position is independent from placing the object in the first position. Thus, without necessity of writing all possible permutations, we can find total number of ways to put 3 different objects in 2 different places as 3 times 2, that is 6. Also, using the equation for k permutation of n, substituting n with 3 and k with 2, we have 2 permutation of 3 is equal to 3 factorial divided by 3 minus 2 factorial. That is equal to 1 times 2 times 3 divided by 1. That is equal to 6. Please pause this video now and take a paper and pen and try to find the equation for k permutation of n by yourself. Let S denote the set of n distinct objects that are numbered from 1 to n. Let's consider k different places that are numbered from 1 to k. S has n distinct objects. Thus, we have n different options to select one of the elements in S and put it in the first place. So, the number of ways we can select an object from S and put it into the first place is equal to n. Let's pick up an arbitrary object from S and put it in the first place. Let's call this object A1. As we chose A1 to put in the first place, we can't put A1 in other places. Let S1 denote the set of all n objects except A1. The number of objects in S1 is n-1. Now we have n-1 options to select one of the objects in S1 and put it into the second place. Let's select an arbitrary object from S1 and put it into the second place. let's call this object A2. We filled up the first and second places with A1 and A2. As we are not allowed to repeat objects in this permutation, we can't use these two objects to fill up the remaining places. Let S2 denote the set of objects that we can use to fill up the remaining places. S2 is the set of all objects excluding A1 and A2. The number of objects in S2 is n-2. Thus, we have n-2 choices to fill up the third place. Let A3 denote the object that we choose from S2 and put it into the third place. Let's continue this pattern iteratively and find number of ways we can put an object in the ith place. Let A1, A2 up to AI-1 denote the objects that we put in places with numbers 1, 2 up to I-1. As we are not allowed to repeat objects in this permutation and we have already used A1, A2 up to AI-1 to fill up places from 1 to I-1, we cannot use these objects to put in the ith place. Let Si denote the set of all objects excluding A1, A2 up to AI-1. The number of objects in Si is n-I-1. Thus, total number of choices to place an object in position number I is n-I-1. Let AI denote the object that we select from Si and put it into place I. As we observe, for any arbitrary number I that is between 1 to k, total number of ways to put an object in place I is n-I-1. Thus, total number of ways to put an object in the last place k is n-k-1. Let AK denote the object that we put it into the last position k. Putting an object in one place is independent from putting objects in other places. Thus, we can multiply the number of ways to put the objects in different places to find the total number of ways we can put n different objects in k different places. So we have k permutation of n equals n times n-1 times up to n-k-1. Now let's use factorial notation to show k permutation of n in a more compact form. Let's multiply both numerator and denominator of k permutation of n by n-k factorial. We keep the multiplication of numbers from n to n-k-1 in the numerator. Let's expand n-k factorial as multiplication of n-k up to 1 in the numerator. Let's keep n-k factorial in the denominator. The numerator is multiplication of all integer numbers from n to 1, so it is equal to n factorial. The denominator is n-k factorial. Therefore, we obtain k permutation of n without repetition as n factorial divided by n-k factorial. Thank you for watching this video. Please subscribe to this channel to watch and learn more about conceptual mathematics problems. If you enjoyed this video and find it useful, please press the like button or write a nice comment to make it more visible for other audiences.